So now we need to find the maximum force exerted to the ball, on the ball. Here force is not constant, it was described, so let me draw it in terms of graph. So force and the time. Force in terms of Newton and the time in terms of second. Initially, at the beginning, force increases linearly for 4 milliseconds. So it was 0, then it becomes, it reaches its maximum value, which is unknown. Let me call it Fm during the 4 milliseconds. So here we have a second graph. So it means 0.004 seconds. If the force on the ball increased linearly for 4 milliseconds, held constant for 20, so next 20 seconds, so here it will be 24 milliseconds, 0.024. So this range is 20 milliseconds basically. Force is constant. And then force decreases to 0 linearly again in another 4 milliseconds. So linearly it reaches another 4 milliseconds. It means it will be 0.028. Yes, if we add 4 milliseconds, and this range again equal to 0.004. We have this kind of graph. We need to find maximum force. So we have a force and a time graph. It means the area of this, under this line, this area will give us the impulse. The area of this figure, the one that I highlighted by red, will be equal to impulse, the meaning of this area impulse, and which is equal to 7.78. We already calculated it. So we can easily find the force, maximum force. So area of this figure, there are so many methods. This is a trapeze, and we know how to calculate the area of trapeze, which is this height. So this is a trapeze. The area of trapeze equal to the height, which is force maximum, times addition of these two lenses. This length equal to 0.02. This length equal to this side 0.028 divided by 2. This is area of the trapeze, which should be equal to 7.78. So from here we can find maximum force, which is, let me use my calculator. So 324 approximately newtons. This is a maximum force applied to the soft ball.